Today we are discussing Lab 1, where we are observing constant velocity. The goal of our lab was to prove Newton's first law, which was an object in motion stays in motion, and an object at rest stays at rest unless acted upon by an external force. The coded model that we used was to replicate the data shown in experiment 1, and this will be shown later on. And the physics fundamentals to understand for this lab was Newton's first law and the position update formula. And you'll see later on as well. And here are the results of our lab. The predicted results were that the velocity should stay constant under an interval of time. And here are our actual results on the graph provided. As you see, the position gradually changed over time, and this change was constant because the graph is linear. There are no fluctuations or errors within our data, and our position gradually changed. And in the equation in the bottom left-hand corner is the position update formula. And this is used later on in the code to prove this right here. The experiment we did. We videoed a marker rolling across a table and used an app called Tracker to essentially take each point, each time interval, and make a point. And those points were taken and the data plots were made into the graph as you saw before. We replicated this data using GlowScript. But before that, here's a video of the marker.
Or can we also do it on here? Or can we also
GlowScript was used to replicate that data very easily. As you see in the code on the top, we used the initial position vector, and then we used the initial velocity. We also set the time start at 0 and the delta t should be at 0.01. The code below is a loop. As you see, Fnet is 0 because there should be no force adding upon it, because when that force is 0, the velocity is constant. As shown, the velocity update formula is the velocity update is left at 0 because there should be no velocity update. But here again is the position update formula. At every time interval, at 0.01 seconds, it is going to update the position with the velocity. And this loop is going to create this model that you see in the bottom left-hand corner, which is going to go across that line and make plots, data points. And those graphs, and that all in turn will make a graph, which will be shown in the next slide. And here are the results of that code. As you see, that is the same graph we had before, proving that we in fact did show Newton's first law. And it also gave us a velocity graph, which shows that the velocity stayed constant throughout, which is very nice. Now, the system and surroundings of our experiment. The system was the marker itself. The surroundings was everything acting upon the marker. For instance, the table was rolling on, the gravity, and the air in the room. Some what ifs to think about. What if the axes were turned around in Tracker? This would not change many things data-wise. This would change the position, as in it would make our positive positions negative, and would change that. And it would also change the, it would just change position. It would make it negative. But the magnitude of the velocity would stay the same, and it would still be constant. Also, what does it mean? They ask, can we determine all the forces acting upon the marker? In theory, we can predict some of the forces, as in the normal force from the table pushing up and the gravity pushing down, but in turn, we cannot predict all the forces. We will know, though, that the net force is 0, so all the forces should equal 0. And to bring it all together, we performed this lab to prove Newton's first law, which we successfully did. The results proved that the velocity stays constant when there is no net force acting upon an object. And thankfully, there was no errors within our experiment. Thank you and have a good day.